again, we've laid out our coefficients from, our quotient that we got, so we reduced it down to one level, and we took the coefficients and laid them out here, and we're going to have to try possible factors of negative 20. Again, possible factors of negative 20 are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20, right? I know what the possible factors of this are, and I'm just going to pick one of those, right? Now, if you didn't know, and if you won't know if you're given a question like this, the best chance that you have of finding a possible factor is starting off with the lowest possible factors first. And the more of these you do, you'll get a pretty good idea of what the possible factor is going to be. Because if you look at this right now, you got a 2 and an 8, which are positive, and you got negative 5 and negative 20. Now, right away, just looking at this, you should have an idea what might work, right? Because right now, the positives add up to 10 and the negatives add up to negative 25, right? So you know one is not going to work, because if everything's just being multiplied by 1, what's going to happen is the positives don't balance out the negatives. Negative 1 is not, it probably is not going to work, okay? So you're going to, you could skip positive 1 and negative 1 and just go to positive 2 and negative 2, okay? So what we're going to do for this is, pick a factor pick a number that I already know is a factor, and we're going to try out x is equal to negative 4, which means x plus 4 is a possible factor of this. So we're going to try out x is equal to negative 4, and if you bring negative 4 over, it just means the factor is x plus 4, right? So what happens is the 2 is going to come down, multiply by negative 4, it's going to come up here, and so forth. So 2 times negative 4 is going to be negative 8. Add them together, you get 0. 0 times negative 4 is just going to be 0. Add them together, you get negative 5. Negative 5 times negative 4 is going to be positive 20. Add them up, you get 0. Negative 20 plus 20 is going to be 0, right? So that means x plus 4 is a factor of this polynomial, right? And what we have down here is the quotient. And one thing to keep in mind is, we have a 0 term here. What that means is, this was x to the power of 3, so we just took out an x from a polynomial, from a function that was x to the power of 3. That means what's left over, the quotient, is going to be x to the power of 2. So this is going to be 2x squared plus 0x, and we don't really need that, right? As soon as you get a 0 in your synthetic division, in the quotients, you can skip those terms, but make sure you keep track of what you're skipping. If that was x squared, that's x squared, right? X to the power of 1 goes here, and that just becomes a constant. Do not put your x over here, because this guy's 0. Everything goes down sequentially, right? Ding, ding, ding. All the powers have to go down in order. So if you have a 0, that uses up, one of the x's, okay? So let's write down the quotient here. What we have now is 2x squared minus 5. Now we're down to a quadratic, right? Something to the power of 2. And, it happens to be two things subtracted from each other. So we can factor this using the difference of squares, or we can factor it using the quadratic formula, or we can just solve for this by setting it equal to 0, moving the 5 over, dividing by 2, and square rooting both sides, which is basically what I'm going to end up doing, right? So what you end up doing for this one, you can factor this one right now, and let's just do it over here. So what we do, we go 2x squared minus 5, you set that equal to 0, bring the 5 over, and then divide both sides by 2. So what you end up having is x squared is equal to 5 divided by 2. And to solve for this, you got to get the x by itself, so you take the square root of both sides, okay? Let's just write that down here, right? Square root of x squared is just going to be x. Square root of 5 over 2, and remember, square root of anything is always plus or minus, so that's going to be square root of plus or minus the square root of 5 over 2, okay? So those are our two other factors, because that's two different solutions, right? So our solutions for that is going to be x is equal to plus or minus 5 over 2. So, going back to our original question where we had, the h of x to the power of 4, the possible factors, or the roots, the zeros, where the h of x, where the function crosses the x-intercept, are x is equal to positive square root of 5 over 2, x is equal to negative square root of 5 over 2, x is equal to negative 4, and x is equal to 3. So there's 4 places where our polynomial crosses the x-axis, okay? And those would be the solutions if that function was equal to 0. But we asked for it to be, the question would have been, if they gave it to you in the function form, to factor that polynomial, right? So we're going to have to write it down and in its factored form. Now, keep in mind, if we're going to have to write this in its factored form, this is square root of 5 over square root of 2. So we're going to grab the square root of 2, cross multiply up here, and take the square root of 5 and bring it over, right? So I'm just going to write these down, both the factors of it in its factored form. That way we're just going to go to the original function and write down what it looks like in its factored form. Okay. So in its factored form, x is equal to plus or minus square root of 5 over 2. It just looks like this, right? Square root of 2x, and the x is not under the square root symbol, right? Square root of 2x minus square root of 5, square root of 2x plus the square root of 5. Again, the x is not under the square root symbol, okay? So let's take all of these and write out the function in, where we start off with, basically. So you know what the original function looks like in its factored form. So h of x, this function here in its factored form, is going to look like the following. That function up there could be written as h of x could be this guy, x minus 3 times x plus 4 times square root of 2x plus square root of 5 times square root of 2x minus the square root of 5. If you FOILed out this whole thing down here, you would end up with your original function. And all of those points means that each one of those is going to be an x-intercept. Each one of those points gives you an x-intercept. Okay. One thing we are going to talk about later on when we start graphing polynomials in a lot more detail, anyway, is whenever you have, a polynomial, a function to a power here, the highest power decides the maximum possible number of x-intercepts that you can have. Okay. So this was x to the power of 4, and the maximum number of x-intercepts we could have had was 4, and we ended up getting 4, okay? You don't necessarily need 4 or get 4. Sometimes you get none, right? But the highest power in any polynomial gives you the maximum number of x-intercepts, okay? And right now, we got 4 x-intercepts. We couldn't have 5 x-intercepts because this was a power of 4, right? So just a pointer for the next stuff coming up. The highest power in any polynomial decides the maximum number of x-intercepts you can have. You can have less than that, but that's the maximum number you can have. Okay. Hopefully this made sense. There's a fair bit of stuff that we did here, a fair bit of calculations, but it's all fairly straightforward. You're bringing numbers down, multiplying by whatever they're coming up, adding them together. You got to know how to use your multiplication table, or you're going to know your multiplication table, and bringing it down. If it's a factor of it, this one wasn't. If that ends up being a 0, that number there is a factor of that guy, that's your quotient. You continue on this one, you use synthetic division on this one until you kick it down to something to a power of 2 or something that you can factor using the other techniques. And then you use that one, you factor it if you can, and you get all the possible factors of your original question that you started with, your original function you started with. Okay? We'll end up doing a couple of more questions at least, and see where it goes from there. Hopefully this makes sense, and it looks fairly easy for you, even though it's taken a fair bit of work to get it done. Okay.